We're now going to use the definite integral to find what I call the total area. Total area in quotes here. Find the total area bounded by the graph of f of x equals x cubed plus x squared minus 6x and the x-axis. So let me show you what I mean by total area and why I put that in quotation marks. So here is the graph of the function that it's talking about. And so if I'm going to try to draw it here, and you see that there's two humps here, and one is a lot bigger than the other. So it goes up, and then it goes down, and it's kind of like this. Okay, that's good enough for our purposes. This isn't quite accurately drawn. This thing should have come down more and up a little bit, but this is okay. So this is x, y, and this is f of x is equal to x cubed plus x squared minus 6x. Okay, so here's what I mean by total area. If I integrated, if I let this be like a and this be b, I'm not going to get the total area under the curve. And by that I mean I'm not going to get like this area, the total area that's bounded by the graph and the x-axis. So this would be the area for this one. This is the area bounded by the graph and the x-axis. This is the area bounded by the graph and the x-axis. So an important thing to realize is if the graph is below the axis, you actually get a negative area. Okay, the definite integral gives you negative area. Okay, and then this gives you positive area. Okay, so if it's above the axis, it gives you a positive area. So this area, if you find the definite integral from here to here, it's not going to give you the total area. It'll take this area and subtract this area, and so it's going to give you less than this area here. Okay, what you really want is you want this area and you want this area. So you got to total those up. And so you need to separate the problem into two integrals. And this integral will give you a negative area, but then you just take the absolute value of that area and add it to this. Okay, so we're going to separate that into two integrals. And so what I need to do is I need to know what these points are. Now this is 0, so I need to know what these points are. So I'm going to have to take this function, set it equal to 0, to find out where this crosses the axis. So I can pull out the x, and then I'm left with x squared plus x minus 6 is equal to 0. And I think this one factors nicely, because 6 can be divided into 2 and 3. The factor 2 and 3 are factors of 6, and this is a negative 6. So one needs to be positive, the other one needs to be negative. So the 3 is going to be positive in order to give me a positive x here. And then the 2 will be negative. So here, this gives me a 0 of x equals 0. This is a root of the equation x equals negative 3, and this one is x is 2. So this point is negative 3. There's your 0. And this should have been negative 2. So this actually should have been closer. This should have went down and up like that is what it should have looked like. So, and then this is 2 here. Okay, so what I'm going to do is integrate from negative 3 to 0. So I'm going to integrate my function here from negative 3 to 0. And this will be x cubed plus x squared minus 6x dx. And that's going to give me this area. That'll give me a positive area. And then I'm going to integrate the same thing from 0 to 2. So let me do this one first so I get the antiderivative. So the antiderivative is just x to the 4th over 4 plus x cubed over 3 minus 6 times x squared. So 6 times x squared over 2. And then I'm going to integrate this from -3 to 0. Okay? So when I plug in 0 into all this, it just goes away. So there's nothing there. And then I'm going to subtract what I get when I plug in -3. So I'm going to subtract, I'm going to put in -3 in here. -3 to the 4th over 4 plus -3 cubed over 3. And then this would be minus, this would be 3, -3 squared. And it'll be the opposite of all that. And I think I'm going to just plug that into my calculator. Okay? And it's still running on fumes because I don't have the charger here. So -3 to the 4th would be the same as 3 to the 4th, and I'm going to divide that by 4 plus, and then I'm going to take -3 cubed, so that would be the, I'll just do it, -3 cubed, and that's divided by 3, and then minus -3 times 3 squared times 3 squared, which is 9. So that's just -3 times 9. So there, let's see what we get. And it says 15.75. And I could probably get that as a fraction. Well, of course I could get that as a fraction. So it's 63/4. Okay, so that's this area right here. So now, what about this area down here? Okay, well that's going to be the integral from 0 to 2 of the same thing. And then I'm going to have the same antiderivative. And this is minus 3x squared. And I'm going to evaluate it from 0 to 2. So I'll put in 2 first, and I get 2 to the 4th over 4 plus 2 cubed over 3 minus 3 times 2 squared. And so then I subtract 0, but when I subtract what I get when I put in 0. And when I put in 0 here, I just get 0. So this would be like minus 0. Minus 0. So let's see what we get here. So this would be 2 to the 4th over 4 is just like 4. That'd be 16 over 4 is 4. And then this would be 2 cubed is 8. So 4 plus 8 thirds. And then this would be minus 12. This would be 3 times 4. And I get this like negative 5.3 repeating, but I could get that as a fraction. And that's negative 16 thirds. Okay? So if you just integrated from -3 to 2, I would have gotten this minus that, okay, is what I would have gotten, and it would have been less than this total area. But if I want the, quote, total area, then I have to split it up into the two integrals and take 63/4 and the absolute value of that, which is 16 thirds. So this would be multiplying top and bottom by 3, 189 twelfths, top and bottom by 4, that would be 40, 64 twelfths, and 189 plus 64 gives me 253/12, which is approximately like 21.08. Okay, which is the sum of those two. And so there you go. That's the total area under a curve. The important thing to realize here is the definite integral gives you positive area for areas that are bounded above the x-axis, negative areas for areas bounded below. So if what you're wanting to get is a total area, then you got to split those integrals up by finding the zeros and then splitting the integrals up. Okay? Let me show you something else. And this is finding the shaded area. So what I want to do is I want to find this area here. Now if I do, so this is 8 up here, so I know that this here is 2, because that point would be 2, 8, because this is the area, or this is the curve y equals x cubed. Okay? So if I do the integral from 0 to 2 of x cubed dx, that'll give me this area here, right? But I want this area there. So one thing that you can do then is to find the area of the square, right? So find this area here. Let's do that first. So this is x to the 4th over 4 from 0 to 2. So this would be 2 to the 4th over 4 minus 0 to the 4th over 4. So that would just be 16 over 4. So that's just equal to 4, actually. So that actually equals 4. So what I could do is find the area of the square, the area of this entire rectangle. And that gives me 8 times 2 is 16. And so then this area is 4. So the area of the shaded region is equal to 16 minus 4, which is equal to 12. So the area of the shaded region is equal to 12. Now what I want to show you here is if you have two functions, let's say this is y equals f of x, and some other function like this, y equals g of x, okay, and you have a and you have b, and there's not really any problems on the homework. I'm just giving you a little bit extra. We actually do this in Calc too. The area between the two curves is actually the integral from a to b of f of x minus g of x d of x. So you subtract these two functions and integrate there, and you actually find the area between them. Now it's important that f of x is greater than g of x, greater than or equal to g of x, for all the greater than or equal to for all x in AB. Okay, so one is above the other. So if they change, and you gotta split up the integral. But if one is above the other the whole time, then you can do this. So this basically is two functions where our f of x is equal to the constant function 8, and our g of x is equal to x cubed. And so our f of x minus our g of x in this case is just 8 minus x cubed. And so I could have integrated from 0 to 2 of 8 minus x cubed dx. And this would have given me the same thing. So this would have been 8x minus x cubed over x to the 4th over 4 from 0 to 2. So then plugging in the 2 would give me this. And then plugging in the 0 just gives you 0, and this is 16 minus 4 which is 12. So you could have thought of it like this as well. So however you want to think of it. For the homework, you could probably think of the problems like this. There's just a couple on there. But then there is this more general result that allows you to find areas of regions that are bounded by two functions. Okay, so that's finding, quote, total area. So we're going to have one last video where I'm going to do an application involving the definite integral, and then we're going to end with that.